Have you ever wondered how a reverse osmosis system takes regular tap water and turns it into clean, great tasting drinking water? Today, we're going to break down how a tanked 4 cartridge reverse osmosis system works in a way that's detailed but easy to understand. A reverse osmosis system, often called an RO system, is usually installed under the kitchen sink. It connects to the home's water supply and treats water for a dedicated drinking water faucet. In some installations, the RO system may also be connected to the ice maker line, so the refrigerator can make cleaner, better tasting ice. A tanked 4 cartridge system typically has 4 main filter stages plus a storage tank. The 4 cartridges usually include Stage 1 sediment filter, Stage 2 carbon pre-filter, Stage 3 reverse osmosis membrane, Stage 4 carbon post-filter. Some systems may also include an additional remineralization filter, which we'll talk about later. The water does not get cleaned all at once. It moves through the system step by step, with each cartridge removing or reducing different contaminants. First, water enters the system from the home supply line. The first cartridge is the sediment filter. This filter removes larger particles from the water, such as dirt, sand, rust, and other small debris. Think of this stage as the system's first line of defense. It protects the rest of the system from being clogged by particles that are large enough to physically trap. After the sediment filter, the water moves into the second cartridge, the carbon pre-filter. This filter is usually made with activated carbon. Activated carbon is very porous, which means it has a lot of surface area inside it. As water passes through, the carbon helps reduce chlorine, taste, odor, and certain chemicals. This stage is important for 2 reasons. First, it improves the taste and smell of the water. Second, it helps protect the RO membrane. Chlorine can damage certain reverse osmosis membranes over time, so reducing chlorine before the water reaches the membrane helps the system last longer. Next, the water moves into the heart of the system, the reverse osmosis membrane. This is the most important stage. The RO membrane is a very thin, semi-permeable barrier. Semi-permeable means it allows some things to pass through but blocks others. Water molecules are small enough to move through the membrane. Many dissolved contaminants are too large or are rejected by the membrane, so they do not pass through as easily. Under pressure, water is forced through the membrane. Clean water passes through to one side. The rejected contaminants are flushed away through a separate drain line. This process can reduce a wide range of dissolved substances such as calcium, magnesium, sodium, chlorides, lead, arsenic, nitrates, fluoride, and many other dissolved solids. This is also why RO water often tests much lower in TDS, which stands for total dissolved solids. TDS is a measurement of the dissolved minerals and substances in the water. A reverse osmosis system can greatly reduce TDS because it removes many of the dissolved materials that regular filters cannot catch. Now, here's an important point. Reverse osmosis works slowly compared to a regular faucet. The membrane makes water carefully, not instantly. That's why a tanked RO system includes a storage tank. After water passes through the membrane, the clean water goes into the storage tank. The tank holds the treated water until you need it. Inside the tank is usually an air bladder. As clean water fills the tank, it compresses the air. That air pressure helps push the water out when you open the RO faucet. So when you turn on the drinking water faucet, you are not waiting for the membrane to make water right that second. You are pulling already treated water from the storage tank. Before that water reaches your glass, it usually passes through the 4th cartridge, the carbon post-filter. This is often called a polishing filter. Its job is to improve the final taste and smell of the water before you drink it. Even though the water has already been through the membrane, it may have been sitting in the tank. The post-filter gives it one last cleanup before it comes out of the faucet. Some systems may also include a remineralization filter after the RO membrane or after the storage tank. A remineralization filter adds small amounts of beneficial minerals such as calcium and magnesium back into the water. Why would we add minerals back after removing them? because RO water can be very low in dissolved minerals. Some people describe straight RO water as tasting flat. A remineralization filter can improve the taste by adding minerals back in a controlled way. So instead of only reducing contaminants, the system can also help create water that tastes more natural and balanced.